So here we are given the acceleration vector a of t, which equals negative 16 cos 4ti plus negative 16 times sine 4t of g plus 4t times of k. And we have to determine this velocity vector using this initial condition, that is the initial velocity equals I plus k. So let's see how to determine this velocity vector. So basically the velocity vector v of t is the integration of the acceleration vector, that is the integral of a of t dt. So now I'm going to write down this integral of a of t. So we have three terms in the acceleration vector, that is for each of the components I, j and k. So basically we have to integrate each of the components of the acceleration vector. So I'm going to write down this first component, that is I component, integral of the I component, that is integral of negative 16 times of cos of 4t, and this is for I component, plus integral of the j component, that is negative 16 times of sine of 4t and dt. I forgot to put the dt here. And this is for j component. And finally, the integral of the k component, that is 4t dt integral, and this is for k component. So now let's start to integrate each of the terms. So in the next step, I write down, we can factor out the numbers, that is negative 16 over here as well as negative 16 as well as this 4 out of the integral, since these are constant. So we will rewrite this as negative 16 times of integral of cos of 4t dt. This is for I component, plus negative 16 times of, we just have to integrate sine of 4t dt. This is for j component, and for the k component, if we factor the 4, it's basically 4 times of integral of t dt, and this is for k component. Now we know that integral of cos function is a sine function. Since we have this cos of 4t, we have to use the standard formula and also divide by the differential of 4t. That is, when you differentiate 4t with respect to time, we get 4. So I'm going to write this as, we have this negative 16, and integral of cos function is sine function. So we put sine of 4t and then divided by this differential component, that is the derivative of 4t is 4. We have to divide that. So this is for I component. Now let's do for j component. So I put this negative 16, and integral of sine function is negative cos function. So I can write down this as negative cos 4t, and once again we have to divide by the derivative of 4t, which is 4, and we multiply and we put this for j component. And finally we just have to integrate the t for the k component. So integral of t with respect to t is using the power rule. It will become 4 times of t squared by 2. This is for k component, and we also put the integration constant c. Now we can cancel this 4 with the 2, so this is basically 2, and so it becomes 2t squared. So I can rewrite this as just a 2t squared. So this is 2t squared for the k component. Now let's write this in simplified form. So for the I component, we see that we can divide the 16 by 4, and this goes 4 times. And similarly, we divide this 16 by 4, and once again this goes 4 times. So for the I component, we have negative 4 times of sine of 4t. This is for I, and we have negative times negative is positive, so this is positive quantity, so can write in the same color as I used before. So this is 4 times of cos of 4t, and this is for j component, plus the k component is 2t square times of k component, plus c. Okay, so we just found this velocity vector, that is v of t, but we have this integration constant c. We have to determine the value of integration constant c and substitute back into this velocity function so that we get the complete velocity vector. For that, we utilize this initial condition, that is v of 0 equals I plus k. So let me copy the initial condition, that is v of 0, this equals I plus k. V of 0 is basically replacing t by 0. So I'm going to do that in this equation. That is v of 0, this equals, we put t equals 0. So therefore this becomes sine of 4 times of 0, that is sine 0. Sine 0 is 0. So this becomes, the I component becomes 0 plus, if you replace t by 0 over here, 4 times of 0 is 0 and cos 0 is 1. So this is basically 1. So 4 times of 1 is 4. So we get 4 times of j plus, if we replace t by 0 here, this becomes 2 times of 0 squared, which is 0. And so therefore it becomes 0 times of k plus c. This means we don't have I component and k component. We only have j component, which is 4j. And now let's replace this v of 0 with this given initial condition. So on the left side, it becomes I plus k. And this side, we have 4j plus c. So to determine the value of c, we have to subtract 4j from both sides. So when we do that, we get the integration constant c equals I minus 4j plus k. So we have determined the value of the integration constant c. We put this back into the velocity vector function so that we get the complete velocity vector. So let's do that. So we write the velocity vector v of t. This equals, the I component is negative 4 sine 4t, negative 4 sine of 4ti plus 4 cos 4tj. This is 4 cos of 4tj plus the k component is 2t square k plus we have this integral constant c. We can replace this c here, that is I plus, I'm sorry, it is I minus 4j plus k. Now since we have another I component, j component as well as k component, we write down using this I component and I component. So we basically combine the I components, j components and k components, and we write down in the simplified form. So therefore v of t, this equals, this is negative 4 sine 4t plus the I component here is 1, the coefficient is 1. So we can write down this as 1 minus of 4 sine 4t. This is the complete I component. Plus, when we combine this j component with this j component, we will get 4 cos 4t minus 4. And this is j component plus 2t square plus the k component is 1 here. So we add 1 and we write down like this. So this is the complete velocity vector. We will now determine the position vector r of t using the initial condition r of 0 equals I plus j plus k. So we write r of t, that is the position vector, is basically the integral of the velocity vector v of t. So we can utilize the velocity vector which we found in part A. So which means we have to integrate each of the terms, that is each of the components, I component, j component as well as k component. So let me write down this r of t. So this equals the integral of the I component, which is 1 minus of 4 times of sine 4t, and this is with respect to time, so we put dt, and this is for I component, plus for j component it is 4 cos 4t minus 4. We integrate with respect to time, so this is for j component, and finally for k component it is 2t square plus 1 dt. This is integral and k component. Now let's integrate each of the terms. So we will have r of t, this equals, we if you look at the I component, we have 1 here. So integral of 1 dt is basically t, and minus we have this 4, and integral of sine of 4t. So this is negative cos 4t divided by the derivative of 4t, that is 4. So I put 4 here, and this is for I component. Now let's do for j component. So we have the term 4 times of cos of 4t. So I put the constant 4 as it is and integrate only the cos of 4t. Integral of cos of 4t is sine of 4t divided by the derivative of 4t, which is 4. Then we integrate this negative 4. So it is negative 4 and integral of dt, which is 4t. So this is for j component. And finally for k component, it is we have to integrate 2t square. So integral of t square is t power 2 plus 1 divided by 2 plus 1 when we use the power rule, that is t cube divided by 3. So it becomes 2 times of t cube over 3 plus integral of 1 is t. This is for k component, and we also put the integration constant c. Let's simplify each of the terms. We see that we can cancel this 4 with 4 as well as this 4 with 4, and let's simplify. So the I component is, we have t, and the negative times of negative is positive, so therefore it becomes t plus cos of 4t. This is for I component, plus the j component is sine of 4t minus 4t. So it is sine of 4t minus 4t, and this is for j component, plus the k component is 2/3 t cube plus t. This is for k component, plus the integral constant c. So this basically represents the r of t. So we have determined this position vector r of t, and we have to find the value of the integration constant c. We can do that using the initial condition, that is r of 0 equals I plus j plus k. So I'm going to use this initial condition, which is I plus j plus k. Let me copy the initial condition. R of 0 equals I plus j plus k. We find this r of 0 by substituting t as 0. So therefore on the left side we will have r of 0, and this equals, we will substitute over here. When we put t equal to 0 here, this will become 0 plus cos of 4 times of 0 is 0. So it is cos of 0. Cos of 0 is 1 times of I, plus if we put t as 0, sine of 0 is 0. So this is 0 minus 4 times of 0 is 0. So we get 0 minus 0 j component, plus we replace t by 0. So 2/3 0 is 0, and t, if we replace 0, it also 0 times of k component plus c. So basically this j component and k component vanishes, and we are just left with only the I component, that is 1 times of I is I plus c. We now replace this r of 0 as I plus j plus k. So we put I plus j plus k over here, and this helps us to determine the value of the integration constant c, and this equals, we can cancel this I. So basically C equals j plus k. So we have determined the value of C, which is j plus k. And so we can now rewrite this complete position vector R of t. So since we have determined this C as j plus k, when we add this 2 over here, basically we just have to add 1 for the j component as well as 1 for the k component, since we don't have I component in the integration constant C. So let me do that. So therefore we will have the complete position vector. This equals, the I component will remain as it is, that is t plus cos of 4t times of I. So let me write down this as t plus cos of 4t times of I, plus I have to add 1 to the j component, that is to this term sine 4t minus 4t plus 1. So it becomes sine of 4t minus 4t plus 1. This is j component. And finally, we will also have to add 1 to the k component, that is to this expression. So it becomes 2/3 t cube plus t plus 1 times of k. So this is the complete position vector R of t.